Hey everyone, thanks for joining the webinar on retail revenue leaks and using AI to stop it. I am Bhaskar Sunkara, founder and CEO of Bicycle. I'm going to do three things in order. Number one, walk through the questions we asked about 100 plus retail and e-commerce leaders about retail revenue in our survey and what the answers tell us. So super excited to share them with you. Number two, share the 7 most common revenue leaks we see in retail. And then number three, we'll drill into 3 of these in detail with concrete examples, and then close with what it looks like when AI can actually help them stop in real time. Real quick, before we begin, quick context, on me. Before Bicycle, I was one of the founders and the CTO at AppDynamics. And AppDynamics was an application performance monitoring company. Back then, the big shift we drove with it was how do we do technical signal to action, right? Especially as software became critical for running a business, but operations was still focused on infrastructure and code. So we moved away from, hey, here's a chart about infrastructure or code, and moving away from that to saying, hey, here's the issue, connected it to user experience with a construct called business transactions. Here's the likely cause. Here's what to do next. That idea changed how teams ran production systems. What we're doing at Bicycle is similar shift, but basically for business signals to action. What are business signals? Right? These are the operational signals that impact revenue. So like drop in revenue for a particular product, store, merchant, etc. These signals usually come from core business data, typically living in a warehouse. Retail teams make hundreds of revenue impacting decisions every day. Pricing tweaks, inventory moves, campaign changes, checkout changes, payment routing, fulfillment promises. But getting from signal, something changing in them, and to action, that loop is very, very slow. When they detect something, to get to action takes a really long time. Speed is the new margin protector, right? It's not just about growth. It's about not losing money quietly while everyone is staring at dashboards. We ran a survey, and the survey is basically a mirror for what's happening inside most retail orgs. And so that's the first part of the webinar. So let's look at this slide to really kind of think about processing this at like an executive snapshot level, right? In terms of just summarizing it. So on the left is the status quo, right? So most revenue impacting issues take about 1 to 5 plus hours to truly resolve, right? And it's not because people aren't smart, right? But because the work is spread out. The middle is the root cause. It kind of tells you why something like this is happening. Ownership is diffused across multiple teams. So you got data, you got product, you got RevOps, you got payments, you got engineering. Everyone is part of the picture. Nobody has the full picture, right? So what happens is people end up staring at dashboards. Everybody has their own dashboards, and they're basically asking, is this real? What changed? Who owns this? And then a Slack thread starts, right? On the right is the shift, right? And this is the core idea of Bicycle and honestly the whole webinar. How do you move from descriptive analytics, which is dashboards that tell you something happened, to agentic analytics, which is systems that can help close the loop end to end, detect, explain, and drive the next step? And the bottom line here is simple. Speed is the new margin protector, right? If an issue runs quietly for 3 hours in a high volume storefront, that's not just a small metric blip. It is real money. So what is the definition, right? Like, so most retail revenue loss, it isn't, we're not talking about something dramatic. It's pretty quiet. We're not talking about dramatic outages where the site is down and everybody knows it. I think most retail leaders already have a ton of monitoring for it. What we're talking about, the hard part, are the quiet leaks, right? The tiny percentage shifts that happen inside high volume moments and compound into real money. Let's look at some examples. So the top search result that someone's looking for is out of stock in one neighborhood, right? Checkout is a little bit slower on a particular mobile version after a release, right? Again, really small. Payment declines creep up for one issuer or one device type. not for everybody, right? So that's again another example. Each one of those sounds small in isolation, but when you multiply it by a million sessions, that's when the drips become floods, right? So that's the lens for everything we'll talk about today. So obviously, we asked a bunch of questions and multiple questions, but I'm not going to cover all of them. I've picked about 5 of them for you, which are also logically in some sequence. The first one I want to cover is we asked everybody, how confident are you that you can detect revenue impacting incidents in real time? More than half, which is a great number, like 56% said they're highly confident. That sounds great. But then we asked the next question, which is not can you detect, but can you resolve? And so then confidence basically dropped as soon as you move from that detection to actually finding root cause, right? And then it dropped again when you move from root cause to actually fixing it to less than 20%. So basically, the disconnect that's really happening is retail leaders feel they should be able to catch issues quickly, but the reality is that the recovery loop of once you catch or you detect the issue and to recover from it is still too slow. Let's move to the next one. How often do customers report a revenue impacting incident before you detect it? Right. This is a super important question, right? Are you the first line of you know reporting where you are detecting it yourself, or are you hearing that from customers? In other words, is your data telling there's a problem, or are your customers basically reporting it to you, right? Like, is your data saying that, or are your customers saying that? For most teams, customers are still the alerting system more than half the time, and that's obviously terrible, right? And it matters because once the customer finds it first, you're not just losing conversion, you're losing trust, right? They're not going to say, "Oh, interesting, it looks like something off with the inventory system, something off, out of sync inventory system is delayed." They just think the store is unreliable, right? So that's the second interesting insight in terms of the question. Detection is imperfect, but when teams detect issues, the bigger problem is like what happens next, right? So after we ask them, like, how often do customers report it directly? The next question we ask is, how long does it actually take to notice, figure out what's really happening, identifying the cause, and fix it? And if you look at this table in this slide, it actually tells the real story. About half the teams notice something is wrong within an hour, but only less than 20% can fix it within an hour, which means the most common pattern is you notice something, then the handoffs start. Data team flags it, right? Product asks for more detail. Engineering checks for releases, like what are the changes, what is kind of really happening in the latest release. Ops basically checks inventory. And then payments basically is checking declines, right? Everybody's looking at their own dashboards, looking at their core data sets. And by the time you get to the real cause, the leak has been running for hours, right? That's why these problems are expensive, not because each issue is massive, but because they run quietly for 1 to 5 hours, which is exactly what most teams reported. As you could guess, right, the next question would be, what are the most common causes? As this slide talks about, there's about like 4 big categories. The first one is inventory issues. It's not just, out of stock issues, right? It's things like inventory is technically available, but not in the right node for delivery. And then online stock and offline, sort of like store stock, they're just not in sync. Then the top search results keeps ranking, even though it's not actually purchasable in that zip code, because again, things are out of sync. Inventory leaks are painful because they create dead clicks. Customers think they're making progress, they hit a wall, right? So that's the first one, inventory issues. Number 2 is partner or API reliability, right? So this is a huge one for marketplaces and even for a lot of direct to consumer stacks, right? Anytime you rely on a third party, it could be a catalog feed, it could be fulfillment partners, tax or shipping calculators, fraud providers. An issue can show up as conversion down even though everything on your site is technically running fine. And the tricky part is it often shows up in a narrow slice. One carrier, one region, one partner, 1 hour of the day. And those are the type that we really want to kind of drill down into more and talk about more, right? Number three, website performance and lag. So this isn't, we're not talking about like the site is down, right? Like it's tiny latency and, user interface, UX friction at decision moments, right? Like add to cart, checkout steps, PDP, etc. A lot of teams underestimate this because 300 to 500, 600 millisecond slowdown doesn't feel like a big deal until it hits mobile traffic at scale, right? And it often correlates with changes, a new release, a new script tag, personalization experiment, and that's kind of really what's causing it. Number four is payment problems, right? This one is especially painful because think about the stage that it happens in, right? Like, because it's happening at peak intent. The customer already has said yes. They're good to go. They're basically buying it right now. They're actually like really checking out and paying it right. Payment issues also hide in slices. Like it can happen for a particular issuer group. It can happen for a particular device or a browser, a particular authentication flow, particular gateway route. So overall, approval rates look fine, while a high value segment is quietly failing. And now the key insight here is not just these are the top four, right? Like, so you had inventory, just to recap, inventory, partner API reliability, website performance and lag, payment problems. All of these are pretty tightly linked. And, it's not just, obviously one owner, because if you think about an inventory mismatch, it can actually look like a checkout drop. And right, a partner latency spike can look like a site performance issue. So they are kind of linked. And also, most retail leaders already have great dashboards for all these four areas. The reason leaks are still happening is dashboards are great at saying, "Hey, something moved," but they don't close the loop on why and what should we do right now, especially when it's slice level, right? It's not systemic and cross team. And so this then sets up the next question. If these leaks span teams and systems, who actually owns fixing them? What is stopping the automation in terms of actually, fixing? The honest answer, and that's what we're getting from the survey, is everyone. There's just, too many folks involved in it. You got data and analytics involved because they're often the first to see the signal clearly and slice it the right way, right? You got RevOps involved because they're usually coordinating the response and trying to protect revenue and customer experience. You've got product involved because a lot of leaks are funnel or merchandising decisions and they own the customer journey. You got engineering involved because site performance, releases, feature flags, integrations, a lot of root causes live there. And finally, you got payments involved because even a small decline in approval rate or auth success, authentication success, can erase a big chunk of revenue quickly. So in practice, a revenue leak isn't just landing in one inbox, right? It lands across five. And when responsibility is spread across 5 teams, what happens is predictable. You get handoffs, you get back and forth, and then you get the Slack thread, right? Sometimes it's a very productive Slack thread, but it's still a Slack thread. And during that time, the leak's still going in the background. Now, the next part of this question is, what is blocking automation? Because every retail leader says they want to move faster. So what actually gets in the way, right? Again, two answers rose to the top. Complexity of integration, integration complexity, and data quality. Integration complexity basically means the signals you need to connect, they're living in too many places, right? Your core transactions might be in the warehouse, most likely are in the warehouse. Inventory, separate system, promotions live somewhere else. Payment auth outcomes are in a gateway dashboard. Fulfillment and everything related to it are in another system. And even if you can access all of them, they're not naturally connected cleanly. Then data quality is the second wall. Even if you hook everything up, still run into incomplete fields, mismatched definitions, time delays. So teams just don't fully trust automation because they've been burned by messy data before. And this is why it's hard to just automate, right? Because automation isn't just a workflow tool. Automation only works if the system can reliably answer what changed, where did it change, why did it change, and what's the safest action to take. So that's the loop, right? Like that's the detect and then sort of like really getting to from detection to action. Most orgs, in a fragmented way, can answer pieces of that, but not end to end and not quickly. So people default back to manual recovery. You have your dashboards, you have your ad hoc queries and Slack triage, even if it takes hours. And because you're used to it, you keep doing that. But if you zoom out, this slide is really, summarizing the survey, right? Like number one, confidence is high. Number two, detection is definitely improving, right? But recovery is still slow because the work is cross team and the data is cross system. All right, so that's the survey. So I wanted to cover about 5 questions, sort of get into the meat of like what were we asking and what we got out of it. And so that's kind of what we got. And so let's move from what leaders say is happening to what do these leaks look like in real life. So what I'm going to do is start with the 7 leaks to begin with, and then we'll basically just drill down into 3 examples of these 7 leaks, right? So this slide that has a list of the 7 leaks, like in all those boxes. Here's the ones that we see most often across retail, right? Like whether they're marketplaces, DTC, D2C, omnichannel, grocery, electronics. It's just the same set showing up with different flavors. So what are these, right? Number one, search mismatch, right? Results of search don't match reality. They're just not in sync. Inventory issues, right? Like there's a mismatch between store versus online, right? Pricing weirdness, like promotion stacking, cannibalization, pricing errors, things like that. Latency tracks, like slowdowns at checkout, for example. Payment friction, right? So could be related to an issuer device, etc. Promise breaks. So this is basically related to buy online and then pick up in store. So BOPIS. So BOPIS cancellations, delivery slot mismatches, could be multiple type of issues there. So that's number 6. And number 7 is returns drag, like so slow refunds, missed exchanges, etc. If you're listening and you're thinking, yep, we have at least 3 of those, that's normal, right? Like these are all, weekly problems. Happens every Monday. Now, just in the interest of time, I'm going to go deeper on 3. Let's start with the leak that's the most common and the most misunderstood: search conversion drops. So imagine something like this, right? Search conversion for eggs drops in Brooklyn. It's not down in Manhattan or it's not down nationally. It's in Brooklyn, and maybe it's for only 2 hours, and maybe it's only on mobile. And that's what these leaks look like. And here's what usually happens when teams look at this for the first time. The first instinct is to treat it as a demand problem, right? But let's go deeper. People might say maybe traffic quality changed. Maybe the campaign brought in worse shoppers, or maybe the creative is wrong. And that's why this is happening. But in retail, a big share of the time, a local search conversion drop is operational, right? Which means it's about how the business is running, not whether there's demand or whether people want eggs today, right? So the way they think about it, and this is what the slide is showing, is a simple 3-step loop, right? Step 1 is detect, right? So now you're selling eggs, in hundreds of areas, right? But you're also selling other items, right? Like it's not just eggs. You've got bread. You could have other sort of like daily items, potatoes, tomatoes, etc. And so what you're doing in detection is you're detecting conversion drop for a particular item in a particular area, right? It is like a total number of items into total number of areas that you're selling in type of problem, right? You need to be able to say eggs in Brooklyn is down, bread in this neighborhood is down, so and so product in this city is down. That's the level at which revenue leaks actually happen. So that's step 1, detect, right? Step 2 is diagnose. Once you know the slice, the question is, why is that really happening? Like, And what makes diagnosis hard is that there are only a handful of likely causes, but they live in different systems, right? So if you look at the list of causes in this particular example, you could be out of stock. So you're either out of stock or effectively out of stock because inventory is not in the right node for that area. You could be having replenishment delays where the item exists, but it's not being replenished fast enough in that neighborhood or store cluster. Price changed. Sometimes you raise prices or remove the promotion and the item became less competitive locally, right? Because again, you're competing with other people who are selling the same thing in the same neighborhood. Third is a catalog issue. The item is available, but the listing is wrong pack size, wrong image, wrong variant, right? Or it's being indexed under the wrong query. And finally, you could have like a competitor price shift, especially in commodity-like items where competitor runs a local promotion and conversion can shift very quickly. Now, the key point is a dashboard might tell you search conversion is down, right? But it doesn't usually tell you which of these is the likely driver, and it definitely doesn't run the test automatically, right? Humans end up doing it manually across systems. So that's step two, like diagnosis and what typically are the type of causes and what actually happens. Step three is action, right? Like you've isolated the cause and you sort of like now determine what to do. The best action is usually simple, not like a big strategy or anything like that, but small fix that stops the bleed. For example, let's just break down some of the possible causes. If it's out of stock, re-rank in-stock alternatives and suppress unavailable options so that shoppers don't hit a dead end, right? You can trigger a restock alert, not a report for a week, and but alert now. If the messaging is wrong, fix availability messaging so customers understand what actually is deliverable. If it's catalog indexing, correct the index, because otherwise they're going into a broken aisle in some sense. If it's a local price competitiveness issue, you don't necessarily need to discount broadly. You may just need a localized promo versus basically saying, hey, the price of this drops across the board, or a quick price adjustment for that slice. Now, the reason this becomes a hard problem at retail scale is the number of combinations just explodes, right? As I was saying earlier, number of items multiplied by the number of areas, right? If you try to handle this with dashboards alone, you end up needing hundreds or thousands of charts, right? By SKU, by category, by city, by neighborhood, by device, by fulfillment method. And that's why teams miss these leaks, not because they don't care, because it's not humanly possible to stare at every slice a day, all day. And this is where I think, obviously AI can do a great job, and, we'll get into that a little bit later. And so using AI can actually go through all the causes. You get an agent to do it, stuff like that, right? So the opportunity is not really build more dashboards, but the opportunity is to start shortening the loop from going from detection to diagnosis to action. You want a system that when this slice drops, immediately asks, is it stock? Is it price? Is it catalog? Is it competition? Right? And gives you a ranked answer plus the next best action while the leak is still small. Right? So that's the first leak. Now let's move from digital to omnichannel, where the leak basically hurts twice, where you're hurting revenue, but you're also hurting trust, right? So this problem is basically this particular leak is promise breaks or purpose cancellation. So you're basically buying online and picking up in store, right? And so like what really happens in this kind of problem? The retail leaks basically get very expensive in here because again, it's hurting multiple things. Like I mentioned, both revenue as well as trust. But here's the pattern, right? Like everything looks fine in aggregate, and then you have one store or one cluster that starts failing, right? So BOPIS cancel rate jumps, and customers feel it immediately, right? So if you look at the slide, the example is like the BOPIS cancel rate at store number 47, right, is up 5 points. And that's a big move. And the important part is when you see that spike, you don't have time for a long investigation. And the important part is yeah, you don't have time for a long investigation. The job is to stop the bleeding. That's the important part before you create a wave of bad experiences. So when purpose cancellations rise, the root causes are usually not, not exotic, right? They're typically, really simple, really straightforward. Number one is inventory integrity gaps. System says the item is available, store reality is different. Maybe there was a miscount, maybe it was moved, maybe it was damaged, doesn't matter. But you know, online promises the item and then picking it up fails basically. That's cause one. Cause two could be labor shortages or scheduling shortfalls. So picking up is a real operation, store is short staffed. Even if the inventory is accurate, orders still won't get picked on time. And what happens next is just very predictable, right? You make pickup windows, miss pickup windows, you cancel orders, and then you have angry customers. Number three is picking or fulfillment delays, even with the staff. If the pick queue spikes, like after school rush, weekends, local promotions, the backlog grows and the store can't keep up with the promise your website made, right? Um, and most companies don't treat those as real-time signals. They treat them as ops metrics that are sort of separate, you know, and then just show up in a weekly review, right? Like you're not combining them with sort of your operational process in general. But by the time you see it in a weekly review, the customer damage is already done, right? So what does good look like here? It's not, you have to do it pretty quickly. That's the main thing. Number one, you can throttle purpose capacity for that store. So don't keep accepting unlimited new pickup orders, and you have to sort of act as the data shows up. Saying if data shows up, if the alert shows up saying store 47 is falling right now, you have to kind of link an action to it, and that's my point of this is a loop, right? Like how do you go from detection to acting on it? And when you have that delay, that's when you start losing revenue, right? So that's what you want to do. Throttle purpose capacity for that store is one of the core actions you can do. Um, the second is flag staffing gaps early, right? Like, so if the spike correlates with a shift change or understaffing, you want to surface that immediately so that the store can basically reassign someone to picking, right? Number three is rerouting or rebalancing. If you have nearby stores, alternative fulfillment mode, you can reroute orders, right? Even a partial reroute can reduce cancellations. And the reason I like this, because makes the concept of real time very tangible, right? Real time doesn't mean we have a dashboard, right? Even if that's streaming real time metrics, right? Real time means we detect the cancel rate spike really quickly. We identify whether it's inventory or labor or backlog. We take the least disruptive action immediately because the customer doesn't experience BOPIS cancellation as a metric, right? They experience it as you told me it would be ready and it wasn't, right? And so that's where you're breaking the trust, and that those are expensive to earn back, right? And so if you look at it broadly, promise breaks are one of the fastest ways to turn revenue leaks into brand damage. But they're very fixable if you detect and respond in the moment instead of after the fact, right? Okay, so that's the second one. So we did, search conversion, then we did like, the BOPIS example, BOPIS cancellation, and then let's do the last deep dive. This is one of the cleanest revenue leak because this is actually about payments, right? Um, and this is obviously where the customer, it is peak intent, as I mentioned earlier, right? So retail teams sometimes, think of payments as owned by a specialized team, or it's handled with a processor, or sometimes it's almost seen as a separate domain, right? But payments are one of the highest leverage places to focus when a payment fails because you're not losing a maybe, you're losing a customer who already decided to buy. They're not adding things to cart. They're not searching. They're basically ready to buy, right? They click pay. They got through checkout. They click pay. That's peak intent. So when you see payment success degrade, even slightly, it's often a bigger revenue hit than a top of funnel issue because you're losing people at the finish line. Now, what does this leak look like in reality? It almost never looks like all payments are failing, right? It's not like systemic. Like I said before, it looks like one slice starts failing, just like the search example, here are common slice patterns that we typically see. Let's look at some examples, right? So payment declines, let's say on high ticket items, because issuer, or because fraud models, etc., they're more aggressive. So high ticket items have more payment declines. Uh, Authentication flows time out on a specific device or a browser combo, especially after a particular release for that. One issuer segment or one card type starts rejecting more than usual because something about the payment request changed. Could be some business rule that really changed. Um, and the root cause can again live in multiple layers. Could be issuer behavior. It could be the gateway route. It could be authentication, changes. Might be latency and timeouts in the redirect flow. It might be a change in checkout that altered the payload slightly, right? The good news is now the operational playbook usually in the payment use cases is straightforward. Number one, detect the slice early. You don't want to detect overall approval rate is bad because that's a very easy one to catch, right? If you want the approval rate sliced by things like device type, browser, issuer segment, payment method, and sometimes even the SKU price band, right? Because that's where the issues are really like hiding. And number two, fix it, right? But fix it in real time. Fail over intelligently in real time. If one gateway route or payment path is wobbling for a slice, you can route that slice through a healthier path. This is one of the simplest and most effective ways to stop a payment leak fast. It's like rerouting traffic around an accident. And number three, offer a sane fallback, right? If the payment path is failing, you can offer an alternate method, wallet, buy now, pay later, et cetera, et cetera. And the important thing here is speed because people don't usually come back the next day to retry a failed checkout. They move on. So you got to cut down on this payment friction. And one of the reasons why this ties back to the survey is that payment issues often require cross team work, payments, engineering, data, maybe even involving the fraud team. So if your organization only detects the issue but can't isolate the cause quickly, the leak runs for hours, right? So again, that's the third leak. Let's just summarize. And we've talked about three leaks: local search conversion drops, BOPIS promise breaks, payment friction at checkout. These are three from the seven that we looked at in terms of typical leaks that happen. Just to again make it real, talk about clear-cut examples, right? And so now I think the next thing we want to do is what changes when again, let's go back to the loop, right? Do you have a loop that basically says detection, diagnosis, and action are in one loop? This is basically where Bicycle fits, right? So with those examples in mind, I think let's sort of look at the shift of how do you move from dashboards, descriptive analytics to an end-to-end loop that actually stops leaks while they're happening, which is agentic analytics, right? So that's kind of the core theme here. So cool. So let's look at the slide, which actually talks about the loop, how to really think about this loop. Everything we've talked about so far is kind of really pointing to this and how we really solve this. If I pick like a very simple observation from the survey, most retail teams already have monitoring tools, analytics dashboards, alert systems, right? So it's not the case that retail leaders are running blind. The problem is that even with all those tools, teams still have long recovery cycles. And with those examples, you can actually feel why, right? Because when search conversion drops or BOPIS cancellations spike in one neighborhood or one store, that's the most important thing. Or payment declines creep up in one device slice, the tools will tell you something moved, right? But they don't complete the loop. They don't reliably tell you why, and they don't drive what to do next. So what happens today is detection is partially automated, but diagnosis and action are still manual. That's why issues take 1 to 5 hours to resolve, and that's why customers still report issues first. And that's why the leak keeps running while people investigate. Now, the shift I'm describing on this slide is really going from a broken chain to a single loop, right? Think of it as 4 steps that run continuously, right? So you have detect signals. This is the something change moment. Search conversion dropped for a particular item or neighborhood. Payment approvals dipped on mobile web for one issue or segment, etc. So this is usually the easiest part. Um, I think what we do at Bicycle to do this is basically using machine learning and find patterns on top of the core data. The second one is really the sweet spot for agents, right? This is where teams get stuck because the cause isn't sitting in that same dashboard system as the symptom. If search conversion drops, the cause might be out of stock, replenishment delays, pricing changes. If BOPUS cancellations spike, the cause might be inventory integrity, labor shortage, payments, dipping, could be authentication flow, gateway route, and these are sort of like all spread out. So this is where you need to kind of think of this as an agentic agentic sort of flow where, you're actually looking at all the drivers quickly and then narrowing it down. And number 3, once you have a likely cause, basically passing on the context to do decision making. What's the safest action that stops the leak without creating a new problem? Do we re-rank listing? Do we throttle pickup slots? Do we fail over to a different route? And this step matters because you don't want just analysis, you want a recommended action. And then you finally take the step, right? Sometimes we automate it, sometimes it's routed to a person, sometimes it's automation with human in the loop. But the action needs to happen fast enough that the issue doesn't sit there bleeding for hours, right? It's basically speed. That is sort of like the margin protector. And this is the bottom line from earlier. Tiny percentage shifts times huge volume equals big money. So if you can shrink time to action from hours to minutes, you're not just improving operations, you're literally protecting revenue. And last part, this is where Bicycle fits, right? It connects your operational signals across the funnel and helps teams move from something's wrong to here's why and here's what to do, right? It would actually go through all the possibilities. Is it sort of like, a labor issue? Is it sort of like a stock issue? Is it a replenishment delay? Like the Bicycle agent will go through all that, and without waiting for 5 different teams to assemble, it will pull data, investigate, and then really kind of close the loop, right? But one of the most important things about this is that you still keep your existing tools, your dashboards, your monitoring, your warehouse. Bicycle doesn't replace those. It sits on top and closes the loop, right? And that is really the opportunity, not more data, not more dashboards. It's a faster loop from detection to diagnosis to action. It's really focused on that, right? So with that loop in mind, let me close with what Bicycle looks like in practice, how teams typically start. So really quick, let's think about a case study. This is a customer deployed in production already. Urban Piper is one of our customers. They're a restaurant commerce platform. They sit in the middle of a pretty complex, world, right? Lot of restaurant locations, lot of ordering channels, a lot of moving pieces. Their big challenge was store availability blind spots, meaning stores would quietly become unavailable or partially unavailable, and the team wouldn't see it fast enough. Sometimes there was a store going offline on one channel. Sometimes menu items weren't actually orderable. And so that kind of pretty much makes it unavailable, even though they looked available, right? Sometimes an integration hiccup made a store appear open when it wasn't, right? And again, these are not dramatic failures. What Bicycle did for Urban Piper was give them a way to monitor availability as a living operational signal, not a weekly metric, not a report. So instead of someone manually checking stores, Bicycle continuously watched the slices that matter by store, by region, by channel, and by key ordering flows and flagged problems early. It then didn't obviously stop at detection. It ran quick diagnosis so the team could tell the difference between a store being truly offline, an integration or channel issue, so on and so forth. And once the likely cause was clear, Bicycle helped route the next step to the right place, whether it was the ops team, the partner channel, et cetera, et cetera. And so the business impact was straightforward for Urban Piper, right? Like fewer auto failures, quicker recovery, and then when something was breaking, a more consistent ordering experience across regions and channels. The win was shrinking the time between something's wrong and it's fixed before it showed up, right? So that's really quickly about one of our core customers and like a use case that's in line with some of what we basically just talked about. Last slide, right? Let's sort of what I'll close with is a simple mental model for where bicycle fits and what the easiest starting point basically looks like. Uh, I like to think of bicycle as a drivetrain, and I love this metaphor because it explains the problem, things we've been talking about for the last half hour. It's the drivetrain that connects both wheels. On the left wheel, you have technical performance, things like page speed, API latency, error rates, plus the stuff that changes all the time: deployments, feature flags, third-party scripts, stock, sync jobs, catalog indexing pipelines. On the right wheel, you have business performance, conversion, add to cart, checkout, success, revenue, fulfillment success, refunds, cancellations, etc. Most companies track these two worlds separately, right? The technical team has their tools and dashboards. The business team has their tools and dashboards. And when something goes wrong, and we saw some examples, what happens is humans try to connect the dots manually, right? Is conversion down because of inventory, or is it because the site is slow, or payment declines up because of issuer behavior, or because the checkout release changed something? That's why in the survey you saw this pattern. People can notice issues pretty quickly, but fixing still takes hours because the organization has to stitch together the story across systems and teams. What Bicycle's agent does is connect these two wheels by default. So when a business signal moves, you can immediately see the likely technical and operational drivers that are causing it. And then most importantly, the next best action, right? So instead of conversion dip, open up 5 dashboards, start a Slack thread and wait for hours. Conversion dipped in this particular slice. So very fine grained, notification. Here are the top likely causes. Again, the notification is routed to the right person. Here's what to do and who should do it. And that is the point of this whole webinar. Speed is the new margin protector. If you can shrink recovery time from hours to minutes, you don't just get better analytics, you stop revenue leaks while they're still small. Right, that's the final story. Retail revenue loss is usually quiet, slice level, and it compounds fast. The teams that win are the ones that go from detection to diagnosis to action. That's the loop I talked about, in minutes, not hours, right? Thanks for spending the time with us. Really, really appreciate it. Feel free to action me. My email's, on that slide, Bhaskar at bicycle.ai. Would love to hear from you. Thank you so much. Bye.